Hello everyone, this is Pankaj from Mastermath.in. In this, we'll be discussing about the 8th chapter, that is trigonometry. This is one of the new topics that we study in the 10th grade. So we have two new topics in for our 10th grade, that is 5th chapter, arithmetic progression, and 2nd chapter is this trigonometry. And of course, the 9th chapter, which is the continuation of this very topic. So we'll continue with this. Now, this is the Thames River of central London, and assuming you have gone for vacations, and by some chance you are staying in this hotel floor, maybe 10th floor of this hotel, and you are asked to measure the width of this Thames River. That too without moving an inch from your balcony. Just give it a thought. I can give you one hint, that is, this forms a right angle triangle, if you notice. This is at 90 degree. Alright, assuming this distance can be ignored, this is a small distance. Now, how do we measure the side B to C, that is the width of this river, without crossing, without taking help of any person? You are only given two things. First thing is a device to measure the length, which is the measuring tape. And you can measure the angle with the device known as theodolite. Just think about it, what you could try. Now, we can't measure AC or side BC just standing on the balcony. Probably we can find AB. If we just drop the measuring tape, it would be fine. It would be easy to find the AB side. So just assume this is 100 meters, and we could measure this angle, say 60 degree. Just keep this example in mind, and we'll come back to this in some time. So these are the prerequisites for this chapter, and hopefully you would be comfortable with this. Pythagoras theorem, taking LCM, basically solving the fractions. So what is the meaning of trigonometry? Just little meaning. So tri means 3, gono means sides, and metry means measurement. So we have to measure something related to three sides, and we all know what is three-sided figure that we see commonly: triangles. So we'll be focusing on triangles. Now, triangles has, there are a variety of triangles: scalene, isosceles, equilateral, right angle triangle, and all other sorts of triangles. Now, we will be focusing only on right angle triangles, just to keep things easy for the start. Now, what does a right angle have? 3 angles and 3 sides. So this trigonometry gives us the relation between the angles of the triangle and the sides of the triangle. Maybe this is side 1, this is side 2. So one angle is related to two sides. So it is similar to what we have studied earlier, I mean in the lower classes. X is equal to y by z. So now if we are having three things and one thing is missing out of any of these three, so we could solve this linear equation and calculate its value. Just like if you have 2 is equal to 3 by x, so x is going to be 3 by 2. So if we are given two values, we could find the third value. So this is the crux, this is the essence of this whole topic of trigonometry. Angle is related to sides ratio. Now coming back to our hotel room, if we are given the side AB, this is one of the sides of triangle, and we need to measure the side BC, and we are given an angle A as 60 degree, we could measure that. So there is something known as trigonometric ratio in trigonometry that we could use to calculate the missing sides. So let me mark it again. This is 90 degree, this is 100, this was 60. So there is something called tangent. It's a trigonometric ratio which relates the opposite side to the angle selected. So we selected angle A, so BC is our side, sides ratio, we discussed about sides ratio. So BC is that side and the side adjacent to the angle, so angle's adjacent side would be AB, and this is angle A, this is the equation. So something called as tangent which relates angle A with with these two sides. Okay, now assuming our angle was 60 degree, in short it is written as tan. So tan 60 is BC by AB, AB is 100, and tan 60 value we already have. You would be given these values and we will be discussing this in the chapter forward. Now assuming its value is 2, BC is unknown, BC is x, and 100, this 100. So x value is going to be 200. Okay, just multiply this, and this is the BC value. So we got the width of the river, the Thames river, without even moving an inch from our balcony of the hotel room. So isn't that very powerful? Just standing at a point we could measure the width of this river. Likewise, we can use this for a lot of other places. Just you could use this to find height. Suppose you could have, there is this building, right? So you could stand, just let me draw it. Suppose this was the building, again AB, and you walk from this building to some distance that you could measure is 100 meters, and then suppose this is pretending that's again 60 just to keep our calculations easy. AB is x. So now again tan 60 is x by 100, and this is tan 60. AB by BC is opposite by adjacent. We will be discussing this formula. Don't worry about the formula right now. Just understand that there is something called trigonometric ratio which connects this angle, this is C, with these sides ratio. This is the only thing needed as of now that you need to be aware of. So angle is related to two sides ratio. Now this you can find, x is going to be 200 again. All right. So now let's continue this further, and if we have a right angle triangle, so what different possibilities of the sides ratio we could get. So this is S1, this is S2, this is S3. So I could get S1 divided by S2, I could get S1 divided by S3, I could also get maybe S2 divided by S1. So if this S1 by S2 was half, this would be 2 by 1. So that's a different ratio. So S1 by S2 is different, S2 by S1 is also different. S1 by S3 and maybe S2 by S3. Could you guess what else could we have? We could have S3 by S1 and S3 by S2. So these are the possibilities of different sides ratios that we could have. So how many ratios do we have here? Total 6 ratios. Now could you guess how many trigonometric ratios we would be having? For obvious reasons, it is 6. We will have 6 trigonometric ratios connecting different sides ratio with different angles. Now B is 90 degrees, so we will not be using that, either A or either C. So now let's discuss this. Our first trigonometric ratio is sine, written as SIN in short, assuming it to be A. Let me change the places of A and C so that it becomes easy. So first thing we need to take care is mark the angle A. Once we mark the angle A, once we select the angle A, opposite to that would, obvious reasons, would be called opposite, and the adjacent side to the base of that would be named adjacent. Sometimes I might use base and perpendicular for this also. So just remember, first mark the angle. If we have selected C, then AB would have been our opposite. So we have selected A here, so this is our selected angle, and opposite would be BC, adjacent would be AB, and S2 is the longest side, which is the hypotenuse. Probably everyone is aware of this. Now this ratio is opposite by hypotenuse. Anywhere in a right angle triangle, or for that matter any triangle, as discussed, sine A is the relation of the angle A with the opposite of the triangle and the hypotenuse of the right angle triangle. So this is BC by AC. This is the first one, sine. And second one is cosine, written in short as cos, which is adjacent by hypotenuse, and adjacent would be AB here, and hypotenuse is same, AC. Third one is tangent, which we just studied, tangent, in short written as tan A, and this is opposite by adjacent, opposite by adjacent. So opposite was BC and this was AB. All right. So we have a right angle triangle. We connect sides ratio with different angles, and we get 6 ratios. So 6 trigonometric ratios, and these are the first 3 trigonometric ratios that we have. Now if this is clear, the rest of the things are just the reciprocal of this. So the reciprocal of sine is cosecant, written in short as cosec A, which is 1 by sine A also, and this is AC by BC, hypotenuse by opposite. Cosine, the reciprocal is secant, in short written as sec A, which is 1 by cos. So 1 by cos means AC by AB for this case. Again, if you would have changed the angle C, angle A to angle C, you would have different opposite and adjacent. Hypotenuse is same. And the last one is cotangent, which is written as cot in short, being the inverse, the reciprocal of tan, which is going to be AB by BC. So these are the 6 trigonometric ratios. Uh, Please make note of this. We would be using this just now and for the rest of the chapter. Now, one important thing is the tangent value is the ratio of sine A divided by cos A. So if you note BC by AC divided by AB by AC. So AC would get cancelled and we'll left with BC and AB, which is the tan value. So tan is sine by A, sine A by cos A. So there are 3-4 topics in this chapter, and we have small details like this, like remembering this 6 trigonometric ratio, and the next topic is remembering the different angles. So 0 degree, 45 degree, 60 degree. So we need to, by the end of the chapter, you must be comfortable remembering all these things, and hopefully you understood till now. So let's do one quick example. If tan A value is given to us as 4 by 3, find all other trigonometric ratios. So first thing is marking the angles in the right angle triangle. This is A, this is B, this is C, this is 90 degree. If we select the angle A, this is going to be the opposite, BC, and this is going to be the adjacent. Now here it is given 4 by 3, that means opposite by adjacent, which is the tan A value, the identity, the formula, equated to, that's given 4 by 3. Now opposite is 4 and adjacent is 3, so we'll mark this 4 and 3. In your textbook it is used 4k and 3k because we are taking ratios. If you have any doubt, you can ask me. Just like we took in the 9th grade, we used to see ratio of these angles of a triangle are 2:3:5. So we used to take 2x, 3x, 5x. So it is exactly the same thing. In ratios, we can't take the numerator and denominator as 4 and 3, but just to make keep things simple, we are continuing with 4 and 3. The answer is going to be the same because it's the ratio. So first thing, sine is opposite by hypotenuse. Hopefully you remember this from our past discussion. Opposite is 4. And what is hypotenuse? So because this is a right angle triangle, we can use Pythagoras theorem. AB square plus BC square is equal to AC square, and AC value would be root of 3 square plus 4 square, which is 5. So you could calculate it in detail. This is hypotenuse. So this is 5. So if we would have taken 4k, we would have got this as 5k, and then the ratio would have again be the same, 4 by 5. So we could take this also. In exam, we need to use that as 4k and 5k, and probably your teacher might also suggest. If not, then you can continue with this. But taking 4k and 5k is mathematically accurate way. Second is cosine, which is adjacent by hypotenuse. Adjacent is 3 and hypotenuse is 5. Now cosine is the cosecant is the reciprocal. Tan we already have. Tan is given 4 by 3. Cosecant is reciprocal of sine, so it would be 5 by 4. And same for secant, sec A, that is 5 by 3, reciprocal of cos. And sixth one is reciprocal of tan, which is cot, and that would give us 3 by 4. So these are the values, and we can, if you're not able to remember, just check the above discussion, and you'll in few questions probably you'll start remembering all these values. Now if just for case, if you had selected C as the angle, so opposite side would have been 3. 3 would be opposite, and this would become the base. So tan C is 3 by 4. Okay, and other things would, depending on this 3 by 4 ratio, tan C we could calculate. So sine C would be opposite by hypotenuse. So hypotenuse is the same, that is 5, but what is opposite now? If we are selecting angle C, that is 3, so it is 3 by 5. So when we took sine C, we got 3 by 5, and when we took sine A, we got 4 by 5, because the opposite of the angle changed. So this is very important, and we need to keep this in mind. So quick revision, just to summarize. First thing, trigonometry deals with 3 sides measurement, that is measurement of ratios of triangles, relation of sides and angles in a triangle. So just to start, we started with right angle triangles, and for the whole 10th grade you will be discussing only that. And second thing, because we have 6 ratios, we have 6 trigonometric ratios, and depending on what side is missing, we could use the relevant trigonometric ratio. And if 2 things are given, x is equal to y by z, so if 2 things are given, we could find the third side using this linear equation. So now you could attempt your examples and exercises, and let me know if you have any doubts. Probably you would be able to do. Just revise this again. And apart from that, you might need some algebraic identities like a plus b times a minus b is a square minus b square, and Pythagoras theorem, which I already discussed. So this is what is required for the first exercise, and we'll discuss this, we'll continue this topic in the next video. All right, in case of any doubts, please ask. I would be happy to help. See you in the next video.